Hello, today we're going to cover system of linear equations. As we already know that a linear equation represents a line. Linear equation could be represented multiple different ways, but in order for us to form a graph, the best way to form a linear equation is the slope-intercept form. And most of us remember that by slope-intercept form, which is y is equal to mx plus b. The reason we call that the slope-intercept form is because m is the slope and b is the y-intercept. So we take the word intercept from the y-intercept and we combine them together and we call this form of the equation the slope-intercept form. Now once we have the slope-intercept form of a linear equation, then we could easily draw a graph, which we know that a linear equation always forms a straight line. So if we have two linear equations, that means we'll have two straight lines. Now when we have two straight lines, they can be graphed in such a manner that they may intersect like this, and when that happens, they obviously have different slopes. So when we have different slopes, the lines will intersect. So if we look at the equation y is equal to mx plus b, and the equation of the other line is y is equal to mx plus b, when the values of m in the two equations are different, they will intersect. So if you're looking at the graph and they are intersecting, we know that we have one solution. By looking at the equation, all we have to look at is the slope, the number that is attached with x. And if that number is different, then they will intersect, and again, you will have one solution. The second situation will be when the lines are parallel. If the lines are parallel, that means they have the same slope. That means the value of y is equal to mx plus b as compared to the equation of the second line, y equals mx plus b. The values of m is the same. That's when the lines are parallel. And when the value of m is the same, then you look at the y-intercept values, and if they are different, then the lines will be parallel. This will be the situation when there will be no solution. The third and final situation is when the lines have the same slope and also the same y-intercept. And that is when y is equal to mx plus b, and the other one is y is equal to mx plus b. And for example, if I stick some numbers in there, then I'd say, let's say y is equal to 2x plus 3, and the other one is y is equal to 2x plus 3. That means the slopes are the same and the y-intercepts are also the same, which is essentially the same line. And that means that the first line and the second line are actually coinciding. And when the lines are coinciding, every point is being shared. Every point is a common point. And that is when we say that we have infinitely many solutions. So a quick wrap up. 3 situations. Infinitely many solutions when M1 and M2 are equal. M1 is equal to M2 and B1 is also equal to B2. This is when the lines are coinciding and you have infinitely many solutions. The other situation that I talked about was when the lines were parallel, and when the lines are parallel, that means slopes are the same, but the y-intercepts are different. So if I take that example, I'd say y is equal to mx plus b, and the second one I'm going to say y is equal to mx plus b, and I'm going to call this 2, and I'm going to call this 1. And the example will be y is equal to 2x plus 3, and the other one could be y is equal to 2x plus 4. This is when the slopes are the same. So if the slopes are the same, I'd say m1 is equal to m2, but b1 is not equal to b2. They're not the same. They're different. That is when they are parallel lines, and that is when we have no solution. And wrap it up completely. If I go back to the first example, when the lines were intersecting, that is when two lines have different slopes. They will intersect at a point, and the point of intersection will be that one solution that they have, and that's the situation when I say y is equal to m1x plus b1 and y is equal to m2x plus b2, and if m1 is not equal to m2, m1 is not equal to m2, we don't worry about b1 and b2. They could be the same, they could be different. As long as the slopes are different, we have one solution.